Uh, yes, good evening, guys. Good evening. Welcome to the third class of atomic structure. Yes, Surya Kalavati. Yes, I have come here. Yes, yes, good evening. Yeah, you say good afternoon or good evening, the same thing, it is in the mid time, right? Yeah. Yes, I hope my voice is audible to everyone. Please ensure that my voice is audible. Okay, okay. Yeah, hi. Hi, Maheshwari. Telugu Gaming. You please change your name, man. Arya Telugu Gaming. Your age, sir. Does it really matter? Does it really matter what's my age? Tell me. But I can say that I'm not very old. Okay? I'm not very old. I'm still young. Okay? We will discuss about that. The question you're asking, we will discuss about that. Okay? Within 1 year. Whatever you ask, within 1 year, you will get the answer. Chalo. Okay, you are guessing my age. Okay, now don't guess my age. You please answer to the question which I'm asking. So in a brief, let me tell you what we have discussed in the last class. So guys, we have discussed about the cathode ray and anode ray experiment in the last two class, if you remember, right? Is there any exam tomorrow? Information will be there to you. As of now, I have not prepared any paper. Okay, so from my side, I don't know, I'm not sure, but information will be passed to you people. Yes, you might be having some group, right? In that group, information will be shared if any exam is there. Please stay assured that you will get the information prior to the exam. That is for sure. And one more thing, whether exam is there or not, irrespective of the daily basis, you guys please study whatever we are discussing in the class. We are not discussing much things because we are in the beginning phase. We are discussing very few things in the class. We want you people to cope up with us. Okay, slowly we will increase the speed, but not over here now. Okay, in the class, but that also you will be able to cope up anyway. So let us start the class. So last class and the class before that, we have discussed about the cathode ray experiment and the anode ray experiment. In that, we have discussed that in the cathode ray experiment, the ray starts from cathode, but in the anode ray experiment, ray does not start from the anode. Now my question again, as a repetition, from where the ray starts in the anode ray experiment? Please do answer in the chat section. Gas. Don't say middle, man. Don't say middle, but you say wherever the gas dissociates. It is not like exactly in the middle only gas is there. Gas is there throughout inside the glass tube. So wherever gas dissociates, from there the anode ray start. XYZ area. Okay, some guys, the Sri Vigna. Very cool, sarcastic answer. XYZ area. I told XYZ area, but it doesn't mean that there any XYZ area. Wherever the gas dissociates, from there the positive charged ion gets formed, that passes towards the opposite charged electrode, right? That is the cathode. Yes, where gas dissociation takes place. Very good, very good. Now I have the next question for you people. Like, in which experiment the particle nature depends on the gas we have taken? Please let me know in which experiment the particle, what is going, that depends on the gas we have taken. Anode ray experiment. Anode ray. Very good answer. Very good. Very good. You guys are doing very well. Anode ray experiment. Correct. Okay. Chalo, badhiya, badhiya, badhiya. I didn't get any cathode ray experiment, means you guys are doing well. Now, third question for you people. The third question for you people is, in cathode ray experiment, what is the particle that always comes? Irrespective of whatever the gas you take, the particle will be always the same. What is that particle that is contained in the cathode ray experiment? Electron, negative charged particle. Negative is okay, but electron. More specific answer, electron. Perfect. Electron, it is electron. Super. Okay, now the fourth question for you people. If you compare the E by M ratio of electron and proton, whose value will be larger? E by M ratio of electron and proton, whose value is larger? Electron? Yes. Out of electron and proton, which will get deflected more? Next question, out of electron and proton, which will be getting deflected more and why? Give reason also. Which one will get deflected more and why it will deflect more? Very few people are saying proton also. Can you explain why? Which one will be deflected more? My bad. Electron more deflection. Very good. Why electron will deflect more? Less mass. Very good answer. The reason is due to its low mass. Less mass is there. Lesser is the mass, more is the deflection. Chalo badhiya. Next question is, how much deflection you expect for the neutron inside the tube? Suppose neutron is passing, then how much deflection will happen for a neutron? Neutron, how much deflection? Surya Kalavati, 0, 0, 0, 0. Yeah, very good. Neutron will have 0 deflection because it has no charge. No charge, no deflection, right? Less deflection due to less mass. No, it is not less deflection. All are saying no deflection. Very good. The one who told, only one person told, and man, you please rectify yourself. It is not like mass is less, that's why less deflection or no deflection. Completely 0 deflection will be there because it has no charge. No charge means no attraction, no repulsion, nothing. So electric field will not influence anything. Magnetic field will not influence anything, right? Very good. Okay, you guys are amazing, right? Zing, 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 amazing. Now, let us proceed with the next experiment. But before that, let me tell you the E by M ratio for proton, which we have not mentioned in the last class. E by M ratio of proton, if you talk about, this value is equal to how much? 9.57 into 10 to the power of 7 coulomb per kg, right? You may make it noted here like this. Then E by M value of E by M ratio of electron, if you compare for electron, how much was the value? Can anyone tell? What is the E by M ratio of electron? E by M ratio of electron. E by M ratio of electron. Whatever the values I told, those values are not absolute value for electron, proton, neutron and alpha particle. I have just made some comparison to know which value is greater, which value is smaller. But exact value in terms of coulomb per kg, you answer me. How much is the value of E by M ratio of electron in terms of coulomb per kg? You are saying 1837. That is relative value only. How much charge per AMU mass? I'm not asking mass in AMU. I'm asking kg, coulomb per kg. Yes, 1.75 into 10 to the power of 11. Yes, so many answers I'm getting. 1.75, 10 to the power of 11. Very good. Some person, Swapna, 1.758820 into 10 to the power of 11. Have you really remembered this value? Do you remember this, or you have copied and pasted from internet? If you really remember, then it is very good, appreciable. Okay, so it is, well, no, it is not 1.6 10 to the power of 11, man. It is 1.75. Yeah, it is 1.75 into 10 to the power of 11 coulomb per kg. Now you can compare here. For proton, 10 to the power of 7 is there, and for electron, 10 to the power of 11 is there. That means definitely the E by M value of electron is greater, right? For electron it is greater, so more deflection. For proton it is less value, so less deflection, right? Now proceeding further to the next topic, which is the discovery of neutron. But before that, let me tell you some fundamental particles about which what we have discussed. Okay, fundamental particles that we have discussed. What are the fundamental particles we have discussed is electron, proton. These two I will write for neutron also. Right, for electron, proton and neutron, what are the things we are going to discuss is, for these fundamental particles, the fundamental particles, subatomic particles, whatever we have, for them what is their charge value, what is their relative charge, what is their mass, and here we have E by M value. Right, all this we will be writing here in a table so that we can remember it. I want it to be handy for you people, so please get it noted. If you talk about charge of electron, it is negative charge and proton is positive charge. Values are same, 1.6 into 10 to the power of 19 coulomb. Here also 1.6 into 10 to the power of 19 coulomb. My point is both are having same charge. Both are having same charge, but the difference is what? What is the basic difference between these two? The difference is one is positive, the other is negative value, right? So I can say that if this is -1 unit of charge, then this is +1 unit of charge. Can I say? Because this value and this value, both of these values are same, numerical value is same, only plus minus sign is different. That's why if this value corresponds to -1, this value corresponds to +1. So these charges are called relative charge. Okay, so that is the relative charge, these particles, and these are the things we are discussing now. Next, if you talk about neutron charge is 0, this relative charge is also 0. What about the mass of electron? Mass of electron is 0.0005 AMU, which is, I told in the last class, how much value? 1 by how much? What is the mass of electron? In the last class I told. How much is the mass of electron? 1 by how much? 1 divided by how much was the value? In the E by M calculation I told. 1837. Very good. 1 by 1837. So this is basically 1 by 1837 AMU or 0.0005 AMU. Mass of proton is 1.007 AMU. And mass of neutron is 1.008 AMU. So for approximation, out of electron, proton and neutron, whose mass can be neglected? Whose mass can be neglected out of proton, neutron and electron? Which value is very small out of all? It is electron, electron, electron. Neutron, some people are saying neutron. How, man? It is not neutron. Neutron is the heaviest out of all this. 1.008, 1.007. Both are approximately 1 only. Whereas mass of electron is 0.0005. Means very small value. For that, what I can say is the mass of electron is negligible, and hence in an atom, what are the particles we have inside the atom? Electron, proton, neutron. Out of these three, the mass of electron is negligible. The remaining two are left, proton and neutron. So proton and neutron will decide what is the overall mass of an atom, right? I hope you are getting my point. Electron mass is negligible. One single electron has 1837 times less mass than that of one proton or one neutron, approximately, you can say, right? Yes, Samantha. Sir, worried about the exam? Don't get worried about the exam. Don't worry about the exam. If exam is there, it will be informed to you in the group. Okay, don't worry about the exam. Now, coming to E by M ratio. E by M ratio of electron, we have already discussed 1.75 into 10 to the power of 11 in terms of coulomb per kg. And over here it is 9.57 into 10 to the power of 8. You see the magical number. Here 75 is there and here 57 is there. 7557. Okay. and for the last one it is 0 because charge is 0, 0 by anything is 0, so it is 0, right? I would like you people to remember this table, very easy. Okay, please remember this so that it will be easy for us to do any charge related problems or mass related problems on the fundamental particles, right? Now we have already discussed two things, the discovery of electron and discovery of proton. You wrote wrong. Which one? Which one I have written wrong, you are saying? Acha, it is 10 to the power of 7 by, right? It is 10 to the power of 7. It is 10 to the power of 7. Yes, it is 10 to the power of 7. My bad. Okay, Hemant, is it okay now? Okay. So now, Samantha told that she is getting worried for the exam. For her, I also got worried. Okay, you guys don't get worried for the exam. Anyway, now proceeding further with the third particle, the discovery of third particle. What is that particle? Name the particle which we are going to discuss now. Name the particle which we are going to discuss now. The third fundamental particle, discovery of neutron. Okay, it is neutron. So what happened is, like, we got proton, we got electron, then later Rutherford is the scientist who thought that there might be some neutral particle also inside the atom. In an atom, okay, in an atom there is some neutral particle also. He guessed this way, but he could not do any successful experiment on the same. But the scientist Chadwick, okay, Rutherford just thought of neutral particle, but he did not do experiment much. Chadwick in 1932, okay, discovered neutral. Neutral means electrically neutral, okay, neutral particle in atom called as neutron. Neutral particle, it is neutron, right? What he has done is, you see here what he has done. He has done the experiment something like this. First of all, you people tell me what is alpha particle. What is an alpha particle? Please let me know. Sir, when did we discuss discovery of electron and proton? Siri, what were we doing in the last two class? First class cathode ray experiment we discussed. The cathode ray consists of electron. Means through cathode ray experiment we got to know about electron. And in anode ray experiment, if you take hydrogen gas, Jaswant, yeah, very good question, man. I like your question. E by M for electron is 1837. I told you are saying that is not the exact value. For comparison purpose only we have taken simple numbers. Suppose that you are saying E by M value, okay, E by M value for electron. What is the charge on the electron? I told you 1.6 into 10 to the power of 19 coulomb divided by mass of electron. If we calculate, it will be 9.1 into 10 to the power of minus 31 kg. Okay, this is the actual value. Try to substitute this value and solve it. Are you getting my point? Please substitute these values. Electron charge is this and mass of electron is this. If you solve this, then you will get the value, which is, I told, 1.75. I mean, for electron, 1.75 into 10 to the power of 11 coulomb per kg, right? That is the value in coulomb per kg. I am asking in coulomb per kg. Whatever the value you are saying, 1837, what is the unit of that? There is no unit. Charge, we have no unit over there. The mass we have taken in AMU. I'm not asking what is the E by M value in terms of AMU, right now, relative charge by AMU. I'm not asking that way. I'm asking, this is approx. It is not approx also. It is just for comparison purpose. Similar units when we are taking, then how to compare for electron and proton. For that reason we are doing. Are you getting my point? Also, why neutron is 0, 0, 0, 0, 0? What? Neutron is 0? I didn't get you. Neutron charge is 0. Okay, the charge on neutron is 0. Resna, which one you want to repeat? How did Chadwick determine the mass of neutron? Yeah, I will tell. How did he determine the mass of neutron? Mass. I didn't discuss anything related to the mass till now. The mass of electron. Yeah, how the mass of electron was calculated, you are asking. We will discuss about that later. Okay. After knowing about electron charge, then we will discuss about that. Till now, I have not discussed about that. We will discuss anyway. About the substitution, you don't worry about the substitution. I will tell later from where we got this value. I will tell you. Okay, basically Millikan is the scientist. He has done one experiment called oil drop experiment. What is that experiment? That is not required for us, but I will tell you if required. But the thing is, through his experiment, he calculated what is the charge on single electron, and he got to know that one single electron charge is this value, 1.6 into 10 to the power of 19 coulomb. Okay, so charge on electron Millikan has calculated from his experiment, and E by m value already was calculated by J.J. Thomson, the same scientist who has given the atomic structure concept, right? The theory for atomic structure. So what I can say is Thomson has given E by m value, and this charge value was given by Millikan. If you substitute these two values, then we got this mass of electron. Okay, mass of electron experimentally we have not calculated. Basically, mass of electron we are getting from this E by m value and this value, right now. Basically E by m value, this value already we know. This value is 1.75 into 10 to the power of 11 coulomb per kg. This value we already know. Okay, and this value mass of electron we don't know. Suppose that you don't know the mass of the electron, it is x. So can you solve this equation to get the value of x? You please tell me. I will come back to you, Sri Vigna. I will come back to you in 1 second. Please have some patience. My point is, E by m value already we have calculated when we are discussing cathode ray experiment. Through cathode ray experiment, how much deflection is happening and all. Sir, how you wrote mass of neutron? I will tell you how I wrote mass of neutron. What I am saying, you please listen. E by m value we have already calculated from the experiment, and this charge value we calculated from another experiment, that is done by Millikan. So these two values we got experimentally, but mass of electron we don't know. So if you substitute these two values, then you can find this x value, and that x value is mass of electron, right? Now don't ask how you got this value. Through the experiment only, like how much deflection was happening. I told you deflection depends on 3 parameters. How much charge is there, how much is the mass of the particle, and how much magnetic field, electric field is there. Based on those 3 values, by substituting those values in the equations, we calculated this value through the experiment only, right? We can find x value. Yes, we can find x value. Yeah. Now Sri Vigna asked one question, that is yeah, Gokul, how did you wrote the mass of neutron? I have not written anything about mass of neutron, man. Mass of neutron in the last slide, what I have written is experimentally found only, that we will discuss here in this slide. Okay. Now you don't think of this E by m value now anyway. Now what I am telling is, Chadwick has discovered this neutron, the neutral particle, electrically neutral particle, through this experiment, in which what he has done is, he has taken this type of block from which the alpha particle got emitted. Okay, here we have taken some radioactive substance. Here we have taken some radioactive substance. Radioactive substance means uranium, polonium, kind of some element has been taken that is emitting what? Alpha particle. And I hope you know what is alpha particle. What is alpha particle? In the last class also we have discussed what is alpha particle. Yeah, I am asking what is alpha particle. You have studied this in class 9th also. Yeah, what is alpha particle? Very good, very good. Neha, very good. Indrani, you had this doubt. Yeah, it is not helium, Jaswita. It is not helium. It is helium plus 2. Helium plus 2. From helium, if you remove 2 electrons, then that is doubly charged helium ion. Yes, Mastan, very good. Doubly charged. Doubly positive you should say, not doubly charged. Charged means it is positive charge or negative charged. Very good. Vallabha, positive charged particle made up of 2 protons and 2 neutrons. Very good. Yeah. Okay, super. Simple word you could have written He plus 2. Okay, you should not write this much lengthy. Right? Simply He plus 2. Helium plus 2. Okay. Alpha particle is nothing but of helium with plus 2 charge. Right now, helium plus 2 ion. It is helium plus 2 ion. That is the alpha particle. Alpha particle is coming out from this highly radioactive substance. Then what is happening? This particular alpha particle is going and hitting on this beryllium sheet. Here we have taken beryllium. On the beryllium sheet, this is hitting over here. Okay. After hitting this beryllium, what is happening? I calculated EB value as you said. I got 0. This value. No, then just one, you might have done some wrong calculations. You might have done some wrong calculation for the E by M value. I told you the values, that is, the values I told is 1.6 into 10 to the power of 19 divided by the mass is 9.1 into 10 to the power of minus 31. Right? How can you get this that way? Green color is produced. Are kya bol rahe ho bhai? Here we take minus this, minus 19. Okay, na? That is minus 19. Power is 10 to the power minus 19. Now you get it solved. Jaswant, whatever you asked, you get it solved here. Yes, 10 to the power minus 19. That is minus 19. Okay, that is 10 to the power minus 19. Did I write plus 19? It is minus 19, man. It is minus 19. Yeah, it is minus 19. 10 to the power of minus 19. Okay, you get it changed. My bad. 10 to minus 19. Now solve it, Jaswant. Now get it solved and let me know. All of you may calculate. Use your calculator if you don't want to calculate, but let me know what is the value you are getting. Yeah, Hatmika, we will come back to the experiment. You please calculate the value. That value, how much is coming, you calculate and let me know the answer. Is helium stable or He2 plus? Stable in what aspect you are talking about? Helium is an atom. Helium is noble gas. Definitely that is stable only. Helium plus 2 is highly reactive, highly active particle, highly energetic particle. Helium is, so that way if you talk about helium is definitely stable. Reason being it is noble gas. It will not react that way. It will not react easily. Sirisa, I have a doubt. Yes, please ask. Proceed further with your doubts. Sindhuja, yes, it is minus 19. It is minus 19. Substitute and get the value. How much it is coming, let me know. Sirisa, you can ask your doubt. The metal has positive ion. No, sir. Why can't just travel as a ray, sir, directly from the anode, since we are applying a very high voltage? Because we are applying very high voltage, it does not mean that the ray will be starting from the anode. Remember, what is that ray consist of? Sirisa, you think that ray contains what particle? You tell me, in cathode ray experiment, the ray contains negative charged particle. In anode ray experiment, the ray contains what particle? Sirisa, my question, I hope you got it. I want answer from Sirisa. Sirisa ji, you please answer to the question which I asked. It is positive, right? So in anode ray experiment, the ray contains positive charge. Now from where positive charge will come? If you remember the whole mechanism which I told, the gas will dissociate and it will give the positive charge. Na? Sirisa, are you getting my point? The gas will dissociate and will give the positive charge from the gas. Very good. Do you think the gas is there inside the anode, inside the metal anode? Sirisa, do you think inside the metal anode the gas is stored and from there the dissociation is happening? Yeah. in the discharge tube. Inside the discharge tube, but metal 2 has a positive ion. Metal 2 has positive ion. Okay, you are saying metal 2 has positive ion. I will tell you one thing. You see, metal has so many atoms. In the atom, the positive charge is the nucleus in which the proton is there. Do you think proton can be removed from the nucleus? Electron is there outside. Electron can be removed. Electron can be added. But proton we are not going to remove. Siris, are you getting my point? Just one, 0.175 into 10 to the power of 12. Very good, very good. Just one, very good. That means 1.75 10 to the 11 only, man. That is what I told, 1.75 into 10 to the power of 11. Yes, sir, understood. Very good, very good, very good. Protons, neutrons are inside the nucleus, so we cannot remove. We can remove it. Siri, do you think we can remove the proton and neutron from the nucleus? Inside an atom, the nucleus is there at the center. We will discuss it in Rutherford's experiment also. So nucleus is there inside the atom, inside which the protons and the neutrons are there. They cannot be removed. Only the electron which is outside can be removed or can be added. So whatever the metal is there, it also has the protons, but the proton will not go out from the metal. So only the gas will dissociate to give that proton. I hope you are getting the point. Do we have to remember this value? Only two values are there, Mohan. Only two values for electron and for proton. What is the problem? Very simple value. One is 1.75, the other is 9.57. 7557. Easy, 7557. 5775. Right? Now come back to the experiment. Chalo. So what I can say is radioactive substance is there with us and we have alpha particle coming out from here. If you remember, similar thing we have done in which experiment? Can you tell me? Can you tell me the similar kind of thing we have done in some other experiment also? Like this type of radioactive element will be taken and alpha particle will come. Where we have discussed the similar type thing? You might have studied, yes, Rutherford experiment. Very good. Not in anode or cathode experiment. In the Rutherford experiment, which we have not discussed, in that gold foil experiment. Very good, Saraswati, very good. It is in the gold foil experiment, alpha ray scattering experiment. This alpha particle was there. So alpha particle, similar kind of alpha particle is coming and hitting this beryllium metal sheet. There we have taken gold foil. Yes, there we have taken gold foil. Now we have taken here beryllium sheet. So alpha particle going and hitting on this beryllium sheet, so that what will happen? From this beryllium sheet, some ray has emerged. Some rays are started from this beryllium sheet. Just like in cathode ray experiment, from cathode the rays started. Now in this experiment, from this beryllium sheet, some rays have started. Virat Kohli, yeah, you please listen to me. What I am telling is, we have taken this type of block inside which we have taken here some radioactive substance. This radioactive substance is releasing some alpha particle. That alpha particle is going and hitting on this beryllium sheet. After hitting this beryllium sheet, from this beryllium sheet, this neutral particle, some particle have come, some rays have come. Are you getting my point? Some rays have come. You please don't spam in the chat box. Why only beryllium? This is a good question, Sadhana Padi. This is good question, but you please don't spam the chat box. Explain. I'm explaining only. Sadhana, coming to you. Why beryllium is taken? We can take some other element also. Okay. But he has taken beryllium for his experiment. We can take some other element also. Okay. I will tell you the reaction. I will write the equation. Then you will understand why beryllium is taken. Anyway. Now what I can say is, here after bombarding on the beryllium, after hitting on the beryllium metal sheet, this sheet has released some neutral particles, some rays, and these rays are nothing but of neutron itself. And what happened next? What happened next if I talk about these rays are again going to hit on this paraffin wax. This is paraffin wax. Can you tell me what is paraffin wax? Have you ever heard of paraffin wax? Paraffin wax. Have you ever heard of this word? It was there in class 10th, if you remember. What is paraffin wax? Candle. One way you can think, candle. No. Petroleum product. Very good. Mastan, very good. Petroleum product. So basically, paraffin wax means you can think of Vaseline jelly, right? In winter season, you might be applying Vaseline jelly, or you can say candle. So it is basically a hydrocarbon. You might have studied about alkane, alkene, and alkyne. So I can say this is paraffin wax, means it is hydrocarbon only. It is hydrocarbon containing hydrocarbon CnH2n plus 2. You might be knowing this general formula of hydrocarbon, alkane, and the carbon is usually 20 to 42. How many carbon will be there? 20 to 42 means solid state should be there. Solid state. If you talk about what is the first alkane we have, can you tell me what is the first alkane we have? Name the first alkane. In the alkane series, what is the first alkane? Methane. Yes, it is a gas, right? Methane is a gas. Ethane is a gas. But when you are increasing number of carbon, what is happening is the gas will convert into liquid. Little higher number of carbon there, it will be liquid. Like petrol. Petrol is a liquid. Petrol is also a member of this alkane family only. Okay, octane is petrol itself. Octane means carbon 8 will be there. If carbon 8 is there, that is octane, and that is itself petrol. So very few carbon there, that is gas. Little more carbon, liquid. We have taken very high carbon, 20 to 42. Now it is in which state? C20 to C42. What should be the state? Guess and let me know. Carbon 1, carbon 2, carbon 3 is there. It is kind of gas. Little high carbons, liquid. So now definitely C20 to 42 means it will be semi-solid or solid, right? Liquid, I mean jelly kind of thing. So that paraffin wax we have taken, you can consider it like Vaseline kind of thing. Okay, it is kind of Vaseline kind of thing that we have taken. After hitting this paraffin wax, what we have observed is some other rays are coming, and these are the rays which we know already. These consist of proton, right? Now my question is, don't you think some magical thing is happening here? I will explain. Don't ask. Explain again. Okay, you are not asking, but what I can say is, you must be having some doubt ki, sir, we have done an experiment in which the alpha ray started from here. It is bombarding on this beryllium sheet. After bombarding, some rays are coming, and we don't know what is that ray, right? We don't know this ray, but this ray, after hitting to this paraffin wax, then it is giving protons. Basically, this is neutron itself, neutral particle. How can we know that this is neutral particle? How can we guess that these particles have no charge? Unknown rays. I can say this is unknown rays. Later, he called these rays as neutron. Later he called neutron, but they are unknown rays. Now those unknown rays, how can we say it is neutron? Very good, very good. Someone is saying zero deflection. Very good, man. So thing is, because these rays are not known to us, he tried to carry out how much deflection is happening. No deflection. Very good, no deflection. So he tried to check how much deflection is there, and he got to know that there is no deflection. From which, by applying external forces, external electric field, you can say magnetic field, because no deflection is happening. That's why he told that these rays, which are the unknown rays, which we don't know, those rays are neutral in nature. They have no charge, and he called them the neutron. But once these neutrons are hitting this paraffin wax, they are giving protons. Don't you think it is kind of magic? Neutron is there, neutron is hitting the paraffin wax, and from paraffin wax proton is coming. From neutron, how the proton is coming? Paraffin wax will be heated and it melts, na sir. Paraffin wax will not be heated over here. It is not heating. It is, I'm not talking about heat. Okay, I'm talking about it is colliding. It is bombarding on the paraffin wax. Now, magically the neutron is giving rise to the proton. Why they are neutral? Why they are neutral? Alpha particle, after hitting to this beryllium, from the beryllium itself, inside the beryllium, neutron was there. That neutron has emerged. Okay, due to pressure. Not due to pressure, I can say alpha particle has very high energy. Because it has very high energy, once it collides on the beryllium sheet, what will happen? It will transfer its energy to the beryllium sheet. Beryllium sheet has beryllium atoms, and beryllium atom has its own neutron, and that neutron will go. Why it is going? Why only when alpha particle hitting this beryllium is losing its neutron? Why not some other particle? If you talk about, I can say that the alpha particle has very high energy. When that highly energetic particle is hitting to the beryllium nucleus, then only the neutron will come out. So neutron is coming out here basically, which is the unknown ray here, the neutron. But neutron is giving rise to proton here. How it is happening? Why the rays are bombarding the paraffin wax, those changes into proton? That is what my question. I asked you. So I asked you to guess what should be the answer. Now you listen what is actually happening. It is very interesting, guys. Very interesting experiment. Okay. We might not get much time to discuss all this because NEET will never ask you all this. But try to learn the thing now. What I am saying is it is very interesting topic. You see, first alpha particle came out from here, colliding on this sheet. On this sheet you have the beryllium atom, suppose here. Everywhere beryllium atom is there. From the beryllium atom, nucleus is there. From the nucleus, the neutron got emerged. That particular neutron is neutral in nature, unknown ray. We have checked that it is not getting deflected. For that reason, I am saying this is neutron. That neutron, once hitting this, paraffin wax means, I told you CnH2n, means paraffin wax contains hydrogen, right? That hydrogen is converting into H plus. And what is H plus? Can you tell me? What is H plus? H plus is proton or electron or neutron. What is H plus? Why was that neutron named neutron? Why neutron named neutron? It is a neutral particle, that's why it is neutron. Neutral particles, hence neutron. Yes, H plus is proton, right? That's what I'm saying. Because alpha particle has high energy, we know that energy can neither be created nor be destroyed. I hope that everyone knows. So because alpha particle has high energy, it is transferring its energy to this nucleus of the beryllium, so that with that energy, the neutral particles are coming out. Those neutral particles are also having very high energy. These are going with very high energy, and once hitting this paraffin wax, in the paraffin wax, hydrogen atom is there. You can see in the hydrocarbon, hydrogen is there na. When it is hitting this hydrogen, that hydrogen is converting into H plus, and that H plus itself is the proton. Are you getting this point? Ramarao, I hope you got the point. What I told, once the alpha particle hitting here, the neutron coming, neutron is hitting here, the H plus is coming. It is all due to the energy transfer. Highly energetic particle is hitting, so that hydrogen will be leaving as H plus ion, and that is what the proton. So this way we concluded that this neutral particle is the neutron, right? So I'm not going to write much things over here. Okay, sir, why only paraffin wax is taken? You have asked brilliant question. I was just about to tell that only. You see why we have taken paraffin wax. If I'm taking C20, suppose 20 number of carbon, C20, it will be H how much? 20 double is 40 plus 2, 42, right? C20H42, how much of hydrogen is there? For 20 carbon, there are 42 hydrogen. A large amount of hydrogen atoms are there in the molecule. If large amount of hydrogen is there, don't you think the hydrogen will convert into H plus easily if more amount of hydrogen is there? Did you get my point? What I'm saying is, if you have taken this paraffin wax which contains more amount of hydrogen, then only that hydrogen can convert into H plus easily. But if you take some random XYZ compound which contains very less amount of hydrogen, that hydrogen may not convert into H plus. Hope you got the point. Then can we take alcohol also? Why are you interested in alcohol, man? Charan Kirti. Why are you interested in alcohol? Not good. Okay, in alcohol, do you think we have more number of hydrogen or something like that? Sir, so paraffin wax is made of hydrogen? No, paraffin wax is not made of hydrogen. It is made of carbon and hydrogen. Okay, it is made of carbon and hydrogen. Basically, more amount of hydrogen. For 20 carbon, 42 hydrogen atoms are there. That's what my point was. Okay, I hope it is clear. So some property of neutron, if you talk about neutron, the first property is has high penetrating power. Has high penetrating power. Second point, has zero charge. There is no charge, so zero deflection. Because there is no charge, there is no deflection. Zero deflection in electric field or magnetic field. Third point I can say. What is the third point I can say? It is slightly heavier than proton. Right? It is slightly heavier than the proton. These 3 points you can make a note. What is penetrating power? Penetrating power means I can say like you see what we have discussed over here in this experiment. What I told, alpha particle is passing through this beryllium sheet and releasing the neutrons. These rays are able to pass through paraffin wax and releasing proton, right? That means they are able to pass through. They are able to pass through this paraffin wax. If you keep some metal here, metal of large thickness, if thickness is very high, then the neutron may not pass through. But if the thickness is less here, very thin metal sheet you are taking, through the metal sheet also it can pass. I hope you are getting my point. Through a metal sheet, very thin metal sheet, if the ray is able to pass, then you can say penetration power is there. More thickness is there, still it is able to penetrate, then more penetration power. Right now, the ability to pass through some substance is penetration power. Right? Paraffin wax which has more hydrogen in the place of 42. You don't think much about which paraffin wax we are taking and all. Okay. That is not that important. The main point is neutron got discovered this way. Sir, doubt. If we give, you focus more on the cathode ray and anode ray experiment. Okay. More questions will not be asked from this topic. You should focus more on cathode ray and anode ray experiment. If you give electron, it will give proton. You are saying like Subhash Chandra Bose. Don't be like Bose. He told like, you give me blood, I will give you freedom. Right? You are also saying that way. Yeah. You please ask your genuine doubts. What is the genuine doubt? You please ask. How did Chadwick experiment definitely prove the existence of the neutron rather than just a high energetic gamma ray, which also had been proposed the cause of the observed effect? Vallabha. Good question. Yeah. How it proved the existence of gamma ray? So basically from where the ray has come out, from this particular beryllium sheet, from the atom. From the atom, the ray has started, and that ray, in this particular experiment, whatever the ray came, that only he has named as neutron. How gamma ray gets originated, we will discuss, but it is not a part of chemistry. In physics, you will learn about that, right? Sir, if we give electron, it will give proton because of pressure only, na sir? Please tell. Where you will give electron, where the proton will come? Sir, show the properties. Yeah, you may write the properties. You may write the properties here. These are the properties of neutron, right? These are the properties of neutron. Sir, anode ray has mechanical energy. Like that, is there energy in those unknown rays and cathode rays? Yes, all the ray, whatever we have discussed, the cathode ray, the anode ray, and this neutral particle, neutral ray, all have high energy, high velocity. They move very fast. Okay. Electrons will get deflected more, protons will be less, and the last one will not get deflected. Sir, can't proton come out when He+2 has bombarded the beryllium sheet? Can't proton come out? No, proton has not come out, only the neutrons have come. Now, Sadhana, whatever the question you have asked, I really appreciate, very brilliant question. Now you see what is exactly happening in the above case. Okay, so in this experiment, what is happening? We have taken alpha particle, which is helium 2 and 4, right? That is reacting, that is bombarding on beryllium, which is 4 and 9 over here. So that what will be the product? Carbon. Can you tell me what is the atomic number and mass of carbon? Atomic number and mass of carbon. Quickly. Atomic mass, atomic number of carbon. 6 and 12. Very good. 6 and 12. So here it is 6 and 12. And what else will come is neutron. Atomic number 0, mass is 1. Both side equation is balanced or not, you check. Sadhana, you have asked this question. You now check whether the equation is balanced or not. Atomic number wise, 2 plus 4, 6. When that means here total 6 protons. Helium has 2 proton, beryllium has 4 proton, total 6 proton. This side 6 proton, right? 4 plus 9, total 13. That means total here 13 fundamental particles are there inside the nucleus. Here 12. Means one more left, na? That is this neutron here. Are you getting my point? Sadhana, did you get it? You asked why the proton is not coming out. This is the reason. Okay, this is the reason. The thing is, what is actually happening, we are trying to study that. We are not going to give our own theory and we will say why this is not happening. Okay, whatever experimentally happening, that we are trying to justify. Okay. Yeah, it is balanced. Chalo, badhiya. Any more doubts? Any more doubts? So in the next class, we will start with atomic structure, like atomic models, Thomson model and Rutherford model. We will discuss in the next class. But I just wanted from you people, if you have doubt, please ask. We can discuss them. How did he found that H plus ray is proton? H plus itself is proton, man. Hydrogen having plus charge is proton. If any other species is having plus charge, that is not proton. Only hydrogen with plus charge is called proton. Remember this. Can we take candle wax also, sir? You may do the experiment and you try it. Okay, if you are getting, then well and good. Okay, it is also hydrocarbon basically. I mean, paraffin wax only. Okay, you can take. I have a doubt. Yeah, you please proceed. Siri, please ask your doubt. This experiment is about discovery of neutron. We got neutrons before the paraffin wax. Then why the experiment is continued. Very good. So that neutral particle came out. Once that neutral particle came out, if the neutral particle is having high power, high energy or low energy, to study about that, he has kept the paraffin wax, and what he came to know ki the neutron is hitting the paraffin wax and releasing the hydrogen from the paraffin wax in the form of H plus. That means it is having that much of energy that hydrogen from the molecule of paraffin wax, the hydrogen is plugged out. From that hydrogen also electron is thrown away and the H plus is coming out. Are you getting my point? Means how much energy the neutron is having, how much energy the rays are having. Siri, can you tell me how much energy is there in the ray? In this neutral unknown ray, how much of energy is there? Less energy or more energy? Let me know. How much energy is there? Just one, yeah, we will conclude the class. Sadhana, how can He plus 2 can come from a radioactive element? How can He plus 2? That also we can write in the form of balanced equation. Okay. In physics, you will learn about this in radioactivity chapter. I don't want to extend this topic now. Okay, but in radioactivity chapter, that is complete chapter itself. Okay, so many interesting points are there to be discussed, and we don't have in chemistry. It was there in the syllabus for us, but now it is not there. In physics, you will be studying about that. Sir, in anode ray experiment, the gas in atomic form only, na sir? Anode ray experiment, the gas will be taken in molecular form, but because very high voltage is there, gas means what? H2 gas you are taking, hydrogen and hydrogen. You see here, hydrogen and hydrogen, this is the bond. The bond will easily break because we have very high voltage. After breaking the bond, now what will happen? The hydrogen atom and hydrogen atom is there with you. Now this hydrogen atom is going to convert into H plus. From the hydrogen atom, electron will also get removed. Why electron is getting removed? Can you tell me? First bond is broken. From the hydrogen gas, bond is broken so that hydrogen atom is formed. From this hydrogen atom, why the electron is removed to produce the H plus? Can you tell me why the electron is removed from the hydrogen atom? Please let me know why the electron is removed from hydrogen atom so that H plus is formed. And that H plus is itself the proton. High voltage supplied. Very good, Sirisa. Very good, very good, very good. I hope you got your answer. Yeah, if neutron can't go into think metal, then how can it have penetration power? If metal can't go into think, I didn't get your question. Please send before classes. Yeah, I will send the notes. High voltage. Okay. How find out that H plus is coming from paraffin? Paraffin, how H plus is coming? Arey bhai, paraffin has high hydrogen amount. High amount of hydrogen is there. Now that hydrogen is converting into H plus and is getting released from the paraffin wax surface. Yes. H plus is only called as proton. Yes, it is H plus only called as proton. Oxygen plus, nitrogen plus, this plus, that plus is not proton. Only hydrogen with plus charge is proton. Okay. Yeah. So for today's class, the last question I have for you is, in the anode ray experiment, what gas you have to take inside so that proton will come? Please answer to my question, everyone. My question for you is, what gas you have to take inside the anode ray experiment so that proton will come? Or you can take any gas. Can you take any gas? Or particular gas has to be taken, then only proton will come? Hydrogen, helium, hydrogen, 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 hydrogen. Very good. It is hydrogen. Don't say it is helium. Bhai, if you take hydrogen, then only H plus will form. If you take O2, N2 and all those gas, they will not form H plus. Do you think oxygen can form H plus? Oxygen will not give H plus. Only hydrogen gas will give H plus, and H plus is proton. So in anode ray experiment, if you want to get proton, you want H plus, you have to take H2. So H2 only has to be taken. Any gas cannot be taken. Keep in mind, you cannot take any gas. If you take hydrogen gas, it will give H plus. H plus is called proton. Okay. H plus only you have to take. Sri Vigna, it is H plus. H plus will come from H2. Arey bhai, do you think in the mango plant you will get orange? In the mango tree, you will get mangoes only, na? So H2 will give H plus. O2 will not give H plus. So H plus, if you want, you have to take H2 gas. And H plus is called only the proton. O plus, N plus, C plus, B plus, A plus are not proton. Okay. Is paraffin alkyne? No, it is alkane, higher alkane. Okay, it is higher alkane. Chalo, anyway, we'll end up the class today. And please go through the cathode ray, anode ray experiment and the Chadwick's experiment. In the next class, we will go for the Rutherford's model and Thomson's model. Okay. Chalo, have a great time ahead, guys. Bye-bye. Yeah, we'll meet in the next class. Chalo, bye. Why he had to show the emergence of proton? Sadhana, very good question. That's what I'm saying. to show that nature of neutron, whether it has high energy or low energy. Suppose neutron has low energy, then from the paraffin wax proton will not come out. But if the proton is coming out, then we can say that neutron is also having high energy. We wanted to know what particle is there inside the atom along with electron, proton. What else particle? It is neutron, and neutron has low energy or high energy? It is high energy. Reason is it is able to remove H plus from the paraffin wax. I hope I clarified your doubt. Sadhana. Yeah. Okay. Chalo guys. Bye bye. Thank you for the class. Okay.